Let us understand how we can read the characteristics of sinusoidal function from the given equation of a sine wave. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will understand characteristics of sinusoidal functions. In this worksheet, I have taken 6 equations to discuss. We call these characteristics as parameters of sinusoidal functions. When I say sinusoidal, it means both sine and cosine. Perfect. Now, the question is, we need to find amplitude, equation of axis, period, and phase shift for all these equations. The first one is a general equation where we will try to understand the concepts and then we are going to apply those concepts learned to answer the next 5 questions. Is that clear to you? So it's a very good worksheet where we'll start with a solved example in general and then take up 5 more examples to consolidate our learnings. I hope the concept is absolutely clear. In case you want to learn from me, feel free to send an email on the address given. My students are right there on top of their class getting awards and scholarships, like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. So let us see how do we answer such questions. So let's go through the concept. In general, a sinusoidal function is given by the equation y equals to a sine k x minus p plus q. How do you relate it with a sine graph? Well, a is called the amplitude. So the amplitude in general is a. And it is the distance from axis to the maximum or minimum. So on the graph shown here, that much distance represents amplitude A. It is always positive, so always positive. Right? So from the axis, you can see upward or downwards, but positive value. That is A sine kx. So let me write down A as amplitude. Now let's look into the second parameter or characteristics, which is k. Now k is number of waves in a period of 360. K is number of waves. We can say cycles in 360 degrees. So to find k, what we really do is divide period. We use the period, right? So let me first tell you what a period is, because that is not in that's part C. Period is distance between two, maximum or minimum, where one cycle repeats. So in this particular case, this is a period. You could also consider the 2 points on the axis from where the graph is going in the same direction. So before getting into k, let's write down what period is. Period is where cycle repeats. So sinusoidal functions are periodic, so they repeat after each cycle. What is one cycle? Well, in this case, this is one cycle, right? that which I have highlighted is called a cycle. So we see that it repeats at this particular point. So in this particular case, 180 becomes the period. You get the idea. So period will be, in this case, 180 degrees. Amplitude in this case will be from -1 to 2, which is equal to 3 in this, from this diagram. Now the thing is, how do you find K? Well, to find K, we need to divide 360 degrees by the period. So that we will know how many cycles are there in 360 degrees, correct? Get the idea? Right. Now let's talk about phase shift. For sine waves, they start at the axis. So we have to see the starting point, whether it is to the left or to the right of origin. You see that? So phase shift is starting point, test starting point. Now when I say test starting, remember one thing, that when you're talking about a sine wave, in that case, the wave is like what? Let me draw one here. It starts with 0. So that is sine wave. And let me now sketch a cosine wave. The cosine wave starts with maximum. Do you see that? This is cosine wave. So when you're checking the phase shift for a sine wave, check the axis. For the cosine wave, check the maximum closest to origin, whether it is left or right and how many degrees. Perfect. So in this video, we have taken up all the dimensions in degrees, okay, for independent variable. So I hope with this, the concept is clear, right? Axis Q. How do you find axis Q? Q is the axis. So in this line, which is symmetric, right, which goes through the points where the concavity changes in this particular case, right? So that is called axis of symmetry. In this case, axis of symmetry is 1, right? So y equals to 1 is axis of symmetry in this particular diagram. So I got some parameters listed for the given graph. I think I'll leave this as a question for you to write equation, okay? Now I think you have understood the concept. Let's write down the characteristics from the given equation. The characteristics we are looking into are amplitude, equation of axis, period, and phase shift. The equation is y equals to sine 10 x minus 2 degrees plus 3. So from this equation, what can you say is the amplitude? Compare it with the equation y equals to a sine k x minus p plus q. As you can see, amplitude is the coefficient, right? Which in this case is 1. And therefore, the amplitude A is 1, right? Equation of axis is given by number 3. So equation of axis is y equals to 3. So we can write amplitude A equals to 1, axis is y equals to 3, period. Now to find period, what will you do? Well, k in this case is given to us as 10, right? So k equals to 10. Perfect, this is k. So to find period, we will divide 360 by 10. So when you divide 360 by 10, you get the period, which is 36 degrees. So we get the period of 36 degrees, correct? Phase shift. Phase shift is the value of P, right, from the equation. And so phase shift is 2. And this 2 is to the right. So we can write down phase shift. 2 degrees right. Is that clear to you? So from the equation, it is actually very easy to read all the characteristics. Perfect. Now, here is the second question. I'd like you to pause the video and write down all the answers. So the equation is y equals to minus 4. Let me rewrite the equation slightly bigger. Y equals to minus 4 cos of 3.6 x minus 10 degrees plus 5. So what information can you directly read? Tell me. Minus 4. What is the amplitude? Well, the amplitude is always positive, so it is going to be only 4, right? Equation of axis is 5. You get the equation of axis straight from the Q value. Phase shift also you can read directly. As you can see here, the phase shift is directly written here. So you can write down this value here. Phase shift is 10 degrees. The only difficulty could be for period. So to find period, we know what? K is equal to 3.6 and therefore period will be what? 360 degrees divided by 3.6, right? So that gives you, so when you divide, what do you get? So dividing by 3, you get 100, right? 3.6, it gets cancelled, 100, right? So 100 degrees is the period for this, and therefore we can write this as 100 degrees. Is that clear to you? It is as simple as that. Perfect. Let's take up 3 more examples. Now, I would like you to write all the values and then check with my solution. It should be done within a minute, right? So amplitude being 4, right? 5 is the phase shift axis and 10 is again the phase shift 10 to right. But we have changed the period this time, 1/3. So K is equal to 1/3. So the period will be what? Period will be 360 divided by 1/3. That is 360 times 3. You get the idea. So it's a very long way, right? So 0, 3, 6, 18, 8, 1, 9 and 1, 10, 80. So we get period of 10, 80 degrees. You get the idea. That is how we are going to write this. Question number 5. This time, can you write down all the parameters? What is the amplitude? Amplitude is 1/5. Do you see that? 1/5 is the amplitude. Equation of axis is also straightforward, which is y equals to minus 4, right? Negative 4. Now, phase shift and period are 2 tricky things. Now, in this equation, you will observe that 2 is not factored out. You need to factor out 2 to get the right answer. So first, we should actually factor out 2, right? So we get sine of, within brackets, 2. And when you factor this out, 30 divided by 2 is 15 degrees, right? Minus 4. Now you should write the phase shift, which is 15 degrees left. 15 degrees right, because minus 15. 15 degrees right. And that 2 gives you period. So period will be, since K is 2, period is going to be 360 degrees divided by 2. And that is 180 degrees. So you get 180 degrees as the period for this. Is that clear to you? Perfect. The last question. Now in the last question, we have minus 0.5 cos 0.2x minus 5. I'd like you to pause the video, answer this question, and then look into my suggestions. As I said, some things are very straightforward. Amplitude, positive value always. We get 0.5. And in this case, the axis, we are not adding or subtracting anything. So it is y equals to 0. There is no vertical translation, that means, right? But to get the period and the phase shift, what should you do? You have to factor out 0.2. So we have y equals to minus 0.5 cos of, factor out 0.2, right? And then you get x minus 5 divided by 0.2, right? What is that? 5 divided by 0.2. Let's calculate on the side. 5 divided by 0.2 means 50 divided by 2, which is 25. Do you see that? So we can rewrite this as minus 0.5 cos of 0.2 x minus 25 degrees. So we get our phase shift now, correct? Phase shift is 25 degrees. Is that clear to you? And to find the period, what will you do? To find the period, we have to divide 360 degrees by k, which is 0.2, right? 0.2 means add times 10 divided by 2, that is 1800. Does it make sense to you? Perfect. So with this, we have solved all our questions, right? So we took up, and here is the last question for you. What I would like you to do here is write equation from the graph. So let this be a test question for you after doing this exercise. We have found most of the things on this equation, but I'd like you to complete it. Perfect. So with that, we come to an end of this particular video. I hope. How do we find the characteristics from an equation? Characteristics like amplitude, equation of axis, period, and phase shift is absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.